Hello all students and welcome back to this course. As you know, we just improved the GA, so we have some operators such as crossover and mutation, and we have tried to improve them. So in this session we just wanted to improve the selection procedure. As you know, we just select randomly different paths. Once we just wanted to apply some operators such as crossover and mutation, but here we just wanted to improve the selection procedures, so we just randomly selection some pops here, and we can use this procedure here, relative selection and tournament selection. So we wanted to employ these three strategies to improve the selection procedure. So let's just take a look at the first one, relative selection. The relative selection actually is one of the most wide-separate method that used to select population, to select any index. So let's just take a look at this procedure. So suppose that we have a circle such as this, and we have a different pops. The number of pops would be 7. So as you can see that the share of the 7 pop would be greater than the share of the first pops, so probability of selecting this part would be higher than this probability. So we just wanted to use this concept to apply the relative selection. What does that mean? It means the population with the better cost has a higher probability to be selected. So we have something like that. In general, the probability of this all population, the summation of probability with all population would be equal 1. So this is general rule of probability, and we have for example 7 pops here. So suppose that we just wanted to show this circle in based on the lines. So we have a different population here. Suppose that the probability, the first spot would be P1, and then P2, P3, P4, and we have all the probability of pops here. So the first one we have a P1, and for the second one we just wanted to use a cumulation function. We just wanted to cumulate all probability here. So for here we just have a P1, P2, and P3. We just want some summation of this previous probability, and we have also can apply for the all pops here. So in general we can say that if we just wanted to use this concept here, because we just wanted to use randomly one of these pops. So suppose that if R, which is randomly selected between 0 and 1, would be in this area, it means that R which be greater than 0 and R is less than P1. We just selected pop 1 as our selected index or our selected population, and if R would be in this area, it means that R is greater than P1 and R is less than P1 plus P2. So in this area we just want to select the P2. So bear in mind that here we just have a sum function, a cumulated function here. It means that we just cumulated every probability here. So for the third part, if R which is placed in this area, it means that is greater than P1 plus P2, and it's just less than P1, P2, and P3. I mean that in this area we just selected the third index or pop tree, and this would happen for the pop 4, and would be happens for the pop 5, 6, and 7. So as you can see that if each share has a greater probability, it has a it would be more possible to accept them as a selected index. So for the Matlab code we can use this function. So this C which will equal some pi. We have a different pi here, so we just give us a matrix with this value. So the first element of the matrix would be pi, the second element would be P, the first element of matrix would be P1, the second element would be P1, P2, and the third one would be P1 plus P2 and P3, and the last one would be 1, because we just add all probability here, and we want to just once we just generated R randomly between 0 and 1, we use this function here. I would be find and just find the first index, which is R would be less than C, so C would be our share that we just wanted to find as I. Just bear in mind that for relative selection we use a Boltzmann function. What does that mean? It means that the probability of selecting any given pops which is related to this function, so we use this function here, exponential power minus cost I, C which is the cost function of any given pops, and we have to just normalize all cost here, all probability here. Summation of this value may be greater than 1, so we have to normalize this with this formula, and we have to also apply the selection pressure, because so we just wanted to give higher probability for the best cost, so we have to just modify this code by adding beta here. This is just selection pressure for selecting the best pop here, and also we have to modify the pi with this value, because since we just wanted to apply this probability, apply this formula to the value with the highest with the high numbers, we have some problems to measure the probabilities, so we just normalize this value by adding this parts here. This is a ci divided worst cost. This would be Cmax. So Cmax we just consider as a worst cost of any population, and we just updated this value once we just wanted to run our code. So we have to use this function as a probability for any given pop, and we wanted to use this for the relative selection function. In addition to relative selection, we have another type of selection procedure, and this is the tournament selection. The tournament selection would be quite simple and easy to use. So first of all, we just select randomly n pop, and it would be the tournament size, and then from the selected pop, suppose that we have this tournament size 5, and we just selected randomly 5 index among all pops, and then we just selected the best one. So I think that is so easy and straightforward. So we just explained the two selection procedure here, and the last one would be random selection, and we have just applied it before, so we have a 2 different strategy for selection procedure. Let's just apply them to our Matlab code. So here we just want to add codes to improve our selection procedures. So let's just go to the BGA, and here at first we have to define codes in Matlab. So it would be the selection beta, which be equal to, suppose that it will equal to 0.1, and this is a selection pressure. It would be used for relative selection, and here we have to determine the probability for any given pop. So we have a p here, so we have a probability here, and we want to use a Boltzmann function, so we use this function here. So at first we have to determine the probability, this probability which is exponential power minus beta multiple cost, and we have to just divide it to worst cost, because for the larger values it has a problem. So before that we have to determine the worst cost here and also cost. So cost would be pop.cost cost, and worst cost here would be the cost of the last population. because here we just sorted based on the best value to the worst value, so the last index which contained the worst cost here. And we also updated this worst cost at the end of iteration, and so we add this code to these parts, and worst cost would be, and pop that in, so it's just updated at the end of iteration. And we have to just come up with the worst cost and a cost, so we just have to use it. We just define the P here, and we can also apply so just bear in mind that we have to normalize this P value, so P would be equal P divided sum P. We have just normalized this P, and we just can apply the relative selection here. So let's just go to the relative selection, and we just wanted to use function name relative selection, and this would be I. It just has one input, it is P. So at first we have to use C. What is C? C actually, C would become sum of P. So let's see what is COMSUM actually and how it works for the code. So suppose that we have a C would be rand I rand for this, and if we use just COMSUM cc, so you can see that it's just added together, you know, just use COMSUM function here. So we have just this value, and we have just add this value to this value and put here. Simply COMSUM function. So if just we use sum C, we just obtain this value. So it just we just use COMSUM for this matrix. So we use this idea to determine the index for the relative selection. So at first we have to just generate a R, which is randomly between 0 and 1. So this is our code, and I actually would be find R, which is less than equal C, just one value, and it would be the first one. So let's just save it. So let's be selection. So just want to apply this code to our Matlab file. Here we just use a index here by using the random selection. We just do comment here, and I1 actually would be relative selection with P, and this is I1, and this would be for I2. Just try it and see what happened. So this is we are here, and we have this probability. Just randomly generated this value, and this is our COMSUM. And the last one, just try it, the last one would be equal 1. So, and then select I, and this is the I, so index 12 we just selected here. And for the second one, just stop it. This is for first one, and this is for select second index. So first index would be selected 2, the second index would be 21. So these two indexes just input our crossover. So this is a relative selection, and we successfully apply to our code. So let's just go to the tournament selection. So for tournament selection, we have to use a new function here, function I tournament selection. So we have a p pop and tournament size. At first we have to determine the number of populations, so n would be size pop and 1. So, and then we have to select it randomly one of a group of pop with this size. So j would be rand sample, and this value, and then we have a new cost here. This new cost actually would be for this selected this index. We just put the cost function of the selected index j to this matrix. This is new cost matrix, and we use the sort order. So for the sort function, we have two outputs. The first one is just bring us the cost, the value of the sorted index, and the second one just give us the index. So the index value would be important and would be useful for us. For we use this code here. So it just gave us the value index of this matrix, but we just wanted to the index of the pop, so we use this code here. And we have to determine the best values. So for here, I think that it's better idea to use mean function. So because we just wanted to determine the best value here, so the mean is best, and here we just add a best. So we have used just this function here because we wanted to determine the index of the best value, and this is best index that related to this matrix. So we wanted to determine the index of the pop. So at the end we just use this function here. So let's just save it, and we have to apply this code in this part. We have a pop, and we have also selection, tournament selection. Sorry, we have also tournament size. So we have added to this part here. And we suppose that it's equal to 5. So this is the tournament size. And So let's just try this code. As you can see that if you just selected, it will just go to this function. This is our tournament size, this is the pop, so n would be 50, and this index is just selected here. We have a new cost here, and the best index for this new cost is 5. So here we just wanted to use the second index. So we just define 3 procedures here, and we just wanted to select one of these procedure. So let's just implement some procedure to employ one of these. So we have to employ a procedure to select one of these strategy here. So we have a g, which is rand I between 1 to 3. If g would be equal to 1, we just wanted to use random selection. If g would be equal to 2, we just use a tournament selection, and if g would be equal to 3, we would go to the relative selection. So let's just apply this strategy to the our code. So we here use switch function, switch g, and we have 3 cases. Case 1, case 2, and case 3. So for case 1 we use random selection, case 2 tournament selection, and case 3 relative selection. So add comment here. So for case 1 we use this code. Just randomly selected one of these index. And we can use tournament selection for case 2, I1 and I2, and we can use relative selection for case 3, I1 and I2, and we just remove this part and also this part here. So we have 2 indexes here for crossover I1 and I2. If g would be equal to 1, we use this formula, and for the second condition we use this formula, tournament selection, and for third condition we use this formula. So we can also apply this code for the mutation part. So we have also I1 here. So we just use I1, so I think that we just employ the code here, and let's just try it. And this is g would be equal to 2, and g would be go to this part. So we just apply a tournament selection here, and the first index would be 3 and second index would be 11. So this is just successfully applied, and let's just run our code. So as you can see that our new selection procedure works. So thank you very much for your attention. See you next.